Hello students, good evening everyone. I hope all are doing well. Anyway, welcome back all of you to Infinity Learn JEE YouTube channel by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. I hope I am perfectly audible and visible to each and everyone. Okay, finally we are moving to the next part of the solution chapter, that is about the colligative properties. I hope you guys have revised to the topics that we have covered in the last class. We have talked about the first colligative properties, right? Relative lowering of vapor pressure. Here we are going to discuss the next colligative property, that is our elevation in boiling point of the solution. Yes, elevation of boiling point of the solution. Right, ready? If anyone is watching this particular live, just give me an attendance. Just give me hi in the comments. Mark your attendance. Okay. First, we have to talk about what you mean by boiling point. What do you mean by boiling point? As we already know, right, it is the temperature at which vapor pressure of the solution will become atmospheric pressure, right? So we can define the boiling point of a liquid is the temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure, which means 1 atmosphere, that is equal to the vapor pressure of the solution. That particular temperature is known as the boiling point of the solution, right? So here we are going to discuss about the next colligative property, that is about the elevation of boiling point. As the name itself suggests that there will be an increases elevation in the boiling point, right? If you are adding any non-volatile solute to a solution, what will happen to the vapor pressure? What will happen to the vapor pressure? As we already seen in the relative lowering of vapor pressure, right, our first colligative property. What will happen to the vapor pressure when we are adding a non-volatile solute to the solution? It decreases, right? Vapor pressure always decreases when a non-volatile solute is added to the solution. So obviously what will happen to the boiling point? If the vapor pressure is decreases, if the vapor pressure is very low, we need more energy, right? We need more heat to boil the particular solution, right? So that boiling point increases. So we can derive or define the boiling point of the solution as, if you are adding any non-volatile solute to the solution, for that particular solution, the boiling point is always greater than that of the pure solvent, right? So that increase in boiling point is known as the elevation of boiling point, our next colligative property. Is that clear? Is that clear? For that, we need to draw a graph like this, the vapor pressure versus temperature graph. Vapor pressure versus temperature graph. As we already know, if you are taking a pure solvent, right? If you are taking a pure solvent, what is the value of vapor pressure? Whether it is high or low. It will be always high, right? So I can draw the graph like this. This is the vapor pressure graph for the solvent, right? Solvent. Then if I am adding a non-volatile solute to the particular solvent, a solution is forming, right? A solution is forming. For that, vapor pressure decreases, right? Vapor pressure decreases. So for example, if I am taking the vapor pressure as 1 atmosphere, right? 1 atmosphere. So what will be the corresponding temperature there? What will be the corresponding temperature there? The vapor pressure the temperature at which vapor pressure become equal to the atmospheric pressure is known as the boiling point, right? So this will be the boiling point of the solvent. I can denote it as TB0 or TB0. Is that clear? This is our vapor pressure of solvent, the first graph. Then it is, if you are adding a non-volatile solute to the solvent, it will make a solution having the low vapor pressure, right? Low vapor pressure. So this will be the second graph for the solution, right? Second graph for the solution. If I am taking 1 atmosphere vapor pressure, right? If the vapor pressure is equal to 1 atmosphere at a temperature, that particular temperature is known as the boiling point of particular solution, right? Here I am taking the solvent case. So it is represented as TB0. Not stands for pure solvent. Is the point clear? Okay, my drawing is not that much perfect. This will be a TB0 and we will get the value of TB here. Let's see the NCERT image given here. Okay. I hope it is clear now. Okay, if you are taking the temperature versus vapor pressure graph here, as you can see over here, this orange one represents the solvent vapor pressure, right? Solvent vapor pressure. So if you are taking the 1 atmosphere pressure here, you can see that the particular temperature at which this vapor pressure is equal to the 1 atmosphere. 1 atmosphere is known as the boiling point of the pure solvent, which is denoted by TB0. Not stands for pure solvent, right? Then if you are taking the solution here, this blue part represents the vapor pressure graph for the solution, right? Again, if you are taking the 1 atmosphere pressure at a particular temperature, that temperature is represented as the boiling point of the solution. Boiling point of the solution. Is that clear? Is that clear? Just forget about the previous drawing. This is the exact image of the graph about the vapor pressure versus temperature for the solution if the non-volatile solute is adding to the solution. Is that clear? Right. So, as you are observing here, you may feel like that this TB0 is high or low. TB0 is high or low. This is our temperature and the x-axis temperature increases, right? So TB is always greater than TB0, right? The difference between TB and TB0 is known as the delta TB or the elevation of boiling point of the solution. Elevation of boiling point of the solution. Clear? It's already mentioned here the temperatures at which vapor pressure of the solvent and solution become equal to the 1 atmosphere pressure or 1.013 bar, that is equal to TB0, and the solution it will be equal to the TB. And if you are taking the difference between TB and TB0, you will get the value of elevation of boiling point. Clear? So, the numerical part, or you need to solve the numerical problems by using the colligative property here, that is elevation in boiling point. In experiments, it is shown that for the dilute solution, the elevation of boiling point of the solution. Hi, Lakshal. Good evening. Welcome to the session. Okay. In the case of dilute solution, right? In the case of dilute solution, the experiments shown that it is directly proportional to the molality part, right? For example, if I am taking the elevation of boiling point as delta TB, change in boiling point, right? It is proportional to the molality of the solution, molality of the solute, right? So we can just remove the proportion by using a constant, right? That constant is known as Kb. Otherwise, the name is molar elevation constant. Molar elevation constant or ebullioscopic constant. Clear? For the dilute solution cases, what will happen to the, what is the value of delta Tb? It is equal to Kb into m, where Kb is the proportionality constant, m is the molality given here. Right. As you already know the formula to calculate the molality, right? What do you mean by molality? The number of moles of solute present in 1 kilogram of the solvent, right? 1 kilogram of the solvent. If W2 and M2 are the given mass and molar mass of the solute respectively, 1000 will be the value given here, W1 will be the given mass of the solvent, right? Given mass of the solvent. Then you can find out the M value as W2 by M2 into 1000 divided by W1. If you are substituting the value of M here in this first equation, you will get the expression to find out the elevation of boiling point as Kb into W2 divided by M2 into 1000 divided by W1, where W2 is the weight of solute, M2 is the molecular weight of solute, and W1 is the weight of the solvent in grams. Is that clear? This is a formula you have to keep in mind to solve the numerical problems. Is that clear? Is that clear? Just let me know in the comments. Lakshmi. Right. So we have seen about the formula to calculate the delta TB value, right? Elevation of boiling point. And there is one more formula to calculate the ebullioscopic constant or the molar elevation constant as Kb is equal to, yes, Kb is equal to RTB square divided by 1000 into Lb, where Lb is given as the enthalpy of vaporization per gram of the solvent. If in the question it is given as delta H or Lb value, you can put the equation here, find out the Kb value, then substitute in the elevation boiling point equation, you will get the answer of, okay, you will get the answer of delta Tb or the elevation of boiling point, right? Okay. Similarly here, as we already know, the Lv is equal to delta H vaporization divided by M1. If you are substituting here, again you will get the equation as M1 into RTB square divided by 1000 into delta H vaporization, where delta H vaporization is the enthalpy of vaporization per mole of the solvent. Then R is the universal gas constant, M1 is the mass of the solvent, then Tb is the boiling point of the solution, right? Boiling point of the solution. Then you need to keep in mind that if you are taking the delta H vaporization in the joule unit, you must take R value as 8.314 Kelvin inverse mole inverse, right? Then if you are taking the LV or delta H vaporization as the calorie value, you should take the R value as 2 calorie degree inverse mole inverse. Is that clear? Is that clear? right? Elevation of boiling point is the colligative property. As we already know, if you are solving about the equation for the elevation of boiling point, it depends on the concentration, right? It depends on the concentration of the solute, which means that it is again a colligative property. As we already know, the properties which depends only on the concentration of the solute, not about their identity or nature, are known as a colligative property. So we can consider elevation in boiling point is again as a colligative property. Okay, I hope it is clear for everyone. Now let us practice some questions based on this colligative property. Here is the first question. Four options are given here. You need to identify which one of the following is a colligative property. Which one of the following is a colligative property? Okay, what will be the answer for this question? Options are given here. Vapor pressure, boiling point, freezing point, and osmotic pressure. No answers? Option 4, right? Osmotic pressure. As we already know, there are 4 colligative properties. First one is a relative lowering of vapor pressure. It is already given here only vapor pressure. So it does not consider as a colligative property here. If it is given as relative lowering of vapor pressure, it should be a colligative property, right? Relative lowering of vapor pressure. Then, not about boiling point, elevation of boiling point of the solution, right? Elevation of boiling point of the solution. Then, the next property we are going to discuss in the next class, it is the depression of freezing point of the solution. Depression of freezing point of the solution. Then the last one, osmotic pressure, which is given as correct answer here, option 4. I hope it is clear for everyone. Here is the next question. This is a numerical problem based on the colligative property elevation of boiling point of the solution. Just read the question, give me the answer in the comments. Question is, a solution containing 2 gram of a non-volatile solute, 2 gram of a non-volatile solute in 20 gram of water, 20 gram of water boils at 373.52 Kelvin. The molecular mass of the solute is, we need to find out the molecular mass of the solute, and it is given that this water boils at 373 Kelvin and the Kb for water is given as 0.52 Kelvin kilogram per mole. Just apply the equation for elevation of boiling point. First you need to find out the delta Tb value here. Already Tb and Tb naught values are given here. From that you can identify the value of delta Tb. Just apply the equation of delta Tb is equal to Kb into m. Then you will get the value of molar mass of the solute. What will be the answer for this question? No answers. Okay, what is the data given here? What is the data given here? What is the boiling point of solution given here? If you are adding 2 gram of a non-volatile solute to the 20 gram of water, what is the value of the Tb here? I mean boiling point of the solution. 373.52 Kelvin, right? 373.52 Kelvin. Then, what is the boiling point of pure solvent? Here it is the solvent, it is water, right? What is the boiling point of pure solvent, which means TB naught? What is the value of TB naught? $373, right? That is the boiling point of water given here, 373 Kelvin. So from that we need to identify the value of, need to find out the value of delta TB, right? How we can calculate delta TB here? Delta TB is equal to TB minus TB naught, right? TB minus TB naught. So it will be equal to 0.52 Kelvin, right? We are just taking the answer here, delta TB is equal to 0.52 Kelvin. Then, what is the another data given here? KB is already given. KB is equal to 0.52 kilogram Kelvin kilogram mole inverse, right? So, as we already know, delta TB is equal to KB into M. KB into M. If you are taking the M value here, this will be the equation to calculate the delta TB, right? So put the values of data given here. Delta TB is equal to 0.52 again. Then KB is equal to 0.52 again. Then what is the value of W2? W2 means the given mass of the solute, which is given as 2 gram, right? 2 divided by M2 we need to calculate here according to the question. Hi Ganesh. M2 we need to calculate 1000 into, what is the molar mass given for the, sorry, there is a correction in the equation, it will be W1, right? W1, where is W1 is the given mass for the solvent. What is the mass for the solvent given here? It is 20 gram, right? 20 gram. If you are solving this equation, you will get the value of M2 is around 100. Clear? So option B, option 2 will be the correct answer here. Is that clear? Is that clear? So what you have to do here, by using the given data, you need to find out the value of delta TB, elevation of boiling point. Just apply it on the equation of delta TB is equal to KB into M. Here you need to calculate the molality by using the given masses. From that you can identify the mass of the solute, that is M2 is equal to 100 here. I hope it is clear for everyone. Now let me move to the next question. Yes. What will be the answer for this question? This is a graph given for the solution solvent system for the vapor pressure versus temperature curve. You need to find out the boiling point of the solvent, boiling point of the solvent. Okay, what will be the answer for this question? Hi B. Ganesh Naidu, good evening. What will be the answer for this question? As we already seen about the vapor pressure versus temperature graph for the solvent solution system, right? If you are getting that particular idea, you will get the correct answer here. First, you need to identify which one is the vapor pressure graph for solvent and solute. Then, mark the temperature at which 1 atmosphere pressure is equal to the vapor pressure. Then you will get the correct value of boiling point of the solvent here. I hope this graph is clear for everyone. The first temperature, it is 80. Okay, this is 80, 81, 82 and 83. Okay, what is the answer for this question? Among these two curves, which one is the curve for the solvent? First one or second one? First one or second one? First one, right? First one is the curve for vapor pressure curve for the solvent. Then second one will be the curve for the solution, right? If you are adding a non-volatile solute to the particular solvent, you will get the solution with a low vapor pressure here, right? So, as according to our definition of boiling point, it will be the temperature at which vapor pressure is equal to the 1 atmospheric pressure, right? 1 atmospheric pressure. So, as you already given here, this is the dotted line. If you are marking here for the solvent, what will be the temperature at which vapor pressure is equal to 1 atmosphere? That will be the boiling point of the solvent, right? What is the temperature given here? (82 Kelvin, right? 82 Kelvin, which means option 2 will be the correct answer here. If the question is asking for the boiling point of the solution, what will be the answer? Boiling point of the solution. Again, you need to find out the temperature, right? 1 atmosphere pressure become equals to the vapor pressure at a temperature of 83. Here it is given in the degree Celsius, so answer will be in the degree Celsius only. So for solution, it will be equal to 83 degrees Celsius, right? This is for the boiling point of the solution. Is that clear? Is that clear? Here is the next question. Solve the question fast and let me know the answer in the comments. Okay. The question is 2 gram of a non-volatile non-electrolyte solute is dissolved in 200 gram of two different solvents A and B, whose ebullioscopic constants are in the ratio of 1:8. The elevation in boiling points of A and B are in the ratio of x is to y. What is the value of y? You should give me the answer in the nearest integer. Hi, hello, King 121. Good evening. Okay, what will be the answer for this question? 2 gram of non-volatile solute is added to a solution of 200 gram with two different solvents, right, A and B, and it is given that the ratio for their ebullioscopic constant, which means ratio of Kb values are given here 1:8. You need to find out the ratio of their elevation in boiling point, delta Tb value. Okay, how we can solve this question? How we can solve this question? As we already know, there is an equation to calculate the delta Tb, right? Delta Tb is equal to Kb, elevation constant, into molality. As we already know, a 2 gram of solute is dissolved in 200 gram of this solvent, right? Okay, in this particular case, 200 gram of solvent is taken here, right? For A and B different solvents, they are taking in the same amount of solute and solvent here. So we can say that molality is similar here, right? So here molality value is the same, right? So because 2 gram of solute is added to the 200 gram of two solvents A and B here. So okay, M value is similar here. So we can take the ratio of TB of A, right? Delta TB of A divided by delta TB of B. That is equal to KB of A divided by KB of B, right? Then this ratio is given as 1:8, which means 1/8. It should be equal to the X is to Y, that is the ratio of biblioscopic constant here, right? So if you are solving here, you will get the value of Y is equal to 8 here. Clear? Okay, it should be X by Y is equal to 1/8, then it will be equal to again Y is equal to 8, right? Because X is to Y is the ratio of elevation in boiling point and 1/8 is the ratio of biblioscopic constant for the solvents. I hope it is clear for everyone. Here is the next question, again based on the biblioscopic constant calculation. Okay, the question is a solution containing 2.5 into 10 to the power minus 3 kilogram of a solute dissolved in 75 into 10 to the power minus 3 kilogram of water. It is boiled at 373.535 Kelvin. The molar mass of the solute we need to calculate, and it is given as the Kb value of water is equal to 0.52 Kelvin kilogram mole inverse, and boiling point of the water is given as 373.15 Kelvin. What will be the value of molar mass of the solute given here? Again just applying the equation, right? Delta TB is equal to KB into W2 divided by M2 into 1000 divided by W1, right? So we need to calculate the delta TB value here by taking the difference between TB and TB naught. That is equal to TB. What is the value of boiling point here? Boiling point of the solution 373.535, right? 373.535, that is the boiling point of the solution TB. So if you are taking the difference between 373 minus 373.15, right? Almost 0.385 will be the answer of delta TB here. So if you are applying here 0.385, that is equal to Kb given as 0.52 into W2 is the value of mass of the solute, right? Mass of solute is given 2.5 into 10 to the power minus 3. What is the molar mass given here? We need to calculate, right? M2 into 1000 divided by W1 is the value of solution here, right? 75 into 10 to the power minus 3. If you are solving here, you will get the answer is around M2 is equal to 45 point something. You can use the nearest integer as M2 is equal to 45. Just take the calculation part. The main thing you have to keep in mind that you need to find out the molality part here by using the given data. From there you can identify the value of M2 as 45. Here is the last question from the session. When 3 gram of a substance is dissolved in 100 gram of CCl4, it reaches its boiling point by mass of the substance X is given in gram per mole. Okay, what is the answer for this question? And already given the Kb value of CCl4 as 5 Kelvin kilogram mole inverse. This is a simple question based on the delta Tb value calculation. Okay, what will be the answer for this question? Okay, we need to apply the equation here, right? Delta Tb is equal to Kb into m, where Kb is the elevation constant and m is the molality, right? So, when you are reading about this question, it is given that the delta Tb value is given as 0.60 Kelvin, right? 0.60 Kelvin. We don't want to calculate by using the Tb minus Tb naught here. Then Kb value is already given 5. Molality we need to calculate, right? Molality we need to calculate. From that idea, we need to calculate the molar mass of the substance X, right? So, W2 divided by M2 into 1000 divided by W1. From there, you will get the answer is around 5 into, where W2 is given as 3 gram, right? 3 by M2 into 1000 divided by W1 is the mass of solvent, right? 100. If you are solving here, you will get the answer is around M2 is equal to 250, right? 250 gram per mole, which means option 1 will be the correct answer here. Clear? This is a simple calculation about the value of delta Tb given here. From the question itself, it is the value given as delta Tb is equal to 0.60 Kelvin. Just substitute the given data here, you will get the value of M2, which means the molar mass of the substance X is given as 250 gram per mole. I hope it is clear for everyone. That's all about from my side for today. We have seen about the next colligative property, elevation of boiling point of the solution. As we already know, if you are adding a non-volatile solute to the solution, what will happen to the vapor pressure? Generally, the vapor pressure lowering, right? So that we will get the idea about relative lowering of vapor pressure, which is equal to the mole fraction of the solute. Then obviously, what will happen to the boiling point? Boiling point increases for the solution. So we can define a term here like that, elevation of boiling point, which is given as delta TB is equal to TB minus TB naught, where TB is the boiling point of the solution and TB naught is the boiling point of the solvent, right? Then if you are converting the relation between molality and delta TB here, you will get an equation like delta TB is equal to Kb into M, where M is the molality. From that, you can identify the mass of solute given here as M2. So we can define these as a colligative property, which means it depends only on the concentration of the solute part, right? Okay, there is a general reminder about the AATs for the JEE Advanced 2025. Infinity Learn is providing the all-India test series for the JEE Advanced, so don't miss the opportunity given here. And again, one more opportunity, it is about the college predictor. If you are giving your JEE Main scores in the link which is provided in the description, you will get an idea about the list of colleges you have to get according to your JEE Main scores. So it will be a great opportunity for everyone. So don't miss this also. Link will be provided in the description. Then the last one, if you are not getting any good ranks in the JEE Main exam, there is no need to worry. There will be more exams like a bit set for the private engineering exams. Again, Infinity Learn is providing the test series for some private engineering exams here. You will get a 70% off by using best 70 off code. So just enroll fast. I hope you guys enjoy the session. If you really like the session, hit the like button, share this particular session to your friends. Subscribe our YouTube channel, Infinity Learn JEE YouTube channel. So if you want to get the session PDF here, you must join our Telegram channel, Infinity Learn JEE Telegram channel. You will get the session PDF after each of the session here. Okay, till then, bye-bye all of you. Take care. I will be coming back with the next colligative property, that is the depression of freezing point of the solution in the next class. Till then, bye-bye all of you. Take care. Thank you so much.